皆さん、こんにちは。本日は小児オプラジカンテルコンソーシアム GHIT ファンドが共催
everybody. Thank you for joining us today for this special webinar co-hosted by the Pediatric Praziquantel Consortium and the GHIT Fund. My name is Hayato Urabe of GHIT Fund, and I'll be moderating today's webinar. As many of you who are participating in this webinar may have already heard about it in the press release, the Pediatric Praziquantel Consortium has recently completed a phase 3 study of arpraziquantel for the treatment of pediatric patients with schistosomiasis. Both efficacy and safety results have been positive. This is an extremely significant achievement for the global health industry, and also great news for those who have been waiting for a new drug development for many years, especially preschool children and their families. The GHIT Fund has been providing continuous support for almost 9 years since its inception in 2013, and has been working closely with the Pediatric Praziquantel Consortium to move the program forward. Today's webinar will have speakers who have been involved in the clinical development of arpraziquantel. They will talk about their contributions to the program from their respective perspectives. We will learn about what went on behind the scenes of clinical development and the success of cross-border partnerships. Today, we will connect Japan, India, Germany, Spain, and Kenya. There will be the slides available are from the GHIT the site. So please look at those slides, please. There will be a Q&A session at the end of the webinar, so please send us your questions and comments from the Q&A box. So let me introduce the first speaker. The first speaker is Dr. Benjamin Dälken, Senior Director, Global Program Lead for Immunology and Global Health at Merck. Merck is the leader of the Pediatric Praziquantel Consortium, the company that developed the praziquantel. Dr. Dälken will welcome you on behalf of the consortium. Over to you, Dr. Dälken.
Yeah, thank you very much. Welcome to our webinar on the journey of the Pediatric Praziquantel Consortium. My name is Benjamin Dälken. I'm the Global Program Lead, which means I'm responsible with my team for the development activities. I work at Merck in Darmstadt, Germany. So a few words why the consortium is focused on schistosomiasis in preschool-aged children. First, we have a high prevalence. So in total, we estimate that there are approximately 50 million children that are suffering from schistosomiasis. And this is specifically the age group from 3 months to 6 years that are left untreated so far. Second, we have a high medical need. And this is due to the consequences in this population from the chronic infection. So we have growth impairment, we have learning deficits in this population, but we also have more severe consequences from chronic infection, like, for example, cirrhosis and bladder cancer. Third reason is that preschool-aged children are neglected. And this is primarily due to the lack of suitable pediatric treatment that is tailored for preschool-aged children. This current standard of care treatment, which we all know, praziquantel, is very effective and safe in the adult population and school-aged children, but it is not readily usable to treat preschool-aged children. And also, a dosing scheme for preschool-aged children has not been defined. Therefore, there is a clear unmet medical need for suitable pediatric medication for children aged 3 months to 6 years, preschool-age children. In 2012, we decided that we want to change this. And therefore, we founded the first international non-profit public-private partnership in schistosomiasis. It functions through a novel approach that engages new partners and collaborators as needed. The model is built on a solid governance structure. So we have a consortium board, but we also have cross-functional and cross-partner teams that have specific functions, for example, focusing on development, focusing on the access, and we have several sub-teams. We are supported by key thought leaders. We are supported by funders, and the WHO is also involved. Here you see our vision and mission statements. Our vision is to reduce the global disease burden of schistosomiasis by addressing the medical need of infected preschool-age children, and this includes very young kids, infants and toddlers. Our mission is to develop, register, and provide a suitable pediatric treatment for schistosomiasis in preschool-age children. In the end, I would like to thank all of you for joining us today for this webinar. Check out our website where you can find a lot of content, Pediatric Praziquantel Consortium.org. Let's look forward together for fantastic presentations today. Thank you very much.
Thank you very much, Dr. Dälken. I understand that the audience have now a good image of the approach to the unmet medical needs by the Praziquantel Consortium's international public-private partnership. I attended the consortium meeting many times, and I always learn a lot because that is a very international and professional group.
Next, I'd like to introduce you Dr. Aya Yajima, Regional Advisor, Neglected Tropical Disease Control, Department of Communicable Diseases, WHO Regional Office for Southeast Asia. Dr. Yajima used to be on selection committee of GHIT Fund, and she was engaged in review of Praziquantel Consortium development. Dr. Yajima will be talking about what is schistosomiasis and what is the issue of public health, WHO's control strategy, how Praziquantel positioned. Now, Dr. Yajima, floor is yours. Thank you very much. I am Yajima. I am a regional advisor of MTD, WHO Regional Office for Southeast Asia. I'd like to give you an overview of schistosomiasis. Schistosomiasis is a parasitic disease caused by the parasite schistosome. And there are over 20 schistosoma species. Many of them are infecting mammals. And it is generally believed that there are 5 species that are infecting humans and causing public health problems. And it is estimated that 120 million children and 100 million adults in 52 countries in tropical and subtropical regions of the world live in areas at risk of infection, 90% of which are in Africa. Let me briefly explain the life cycle of the schistosomes. In the case of the schistosome hematobiome, thousands of eggs are shed in the urine of infected people, and in the case of other species, in the feces every day. When these come into contact with fresh water, they hatch into myceliums. These mycelium infect certain snails and develop into sporocysts and cercaria in their bodies. Thousands of cercaria then escape, swim in the water, and penetrate the skin of the hosts, thereby infecting humans and other mammals. Cercaria become adult worms in the body of an infected person while migrating in the bloodstream. When the males and the females meet and start laying eggs, these eggs settle in various places in the infected person's body, causing fever, inflammation, mucosal, bloody stools, ulcers, polyps in the intestinal wall. In the chronic stage, the worm eggs clog the small arteries of organs, causing liver cirrhosis and abdominal distension caused by ascites, which may lead to cause hepatocellular carcinoma, and in the case of schistoma hematobium, bladder cancer. As the name Schistosoma japonicum suggests, Japan was once known as an endemic country, but it was one of the first countries to stop the spread of the disease on its own. The magnitude of the public health problem of schistosomiasis was recognized early on in the world, and soon after the WHO was established in 1948, it was decided to promote research on the transmission and the control, and in the 1970s, a special control program was launched. The WHO Assembly formally called on countries to accelerate research on control and diagnosis. In this context, after the declaration of the global eradication of smallpox in 1980, researchers and policymakers involved in disease eradication and control around the world began to actively discuss which diseases would be next to be eradicated and what conditions would make disease eradication possible. And the following three are agreed upon as the most important conditions. So as for schistosomas, the effective, inexpensive, safe drug have to be available. And also, the simple, rapid, accurate diagnostic tool has to be also available. And then the lifestyle of the pathogens, whether or not humans are living close, and we need to stop the proliferations in the environment, propagation in the environment. So therefore, in 1993, already there was effective, safe, and inexpensive drug praziquantel was available. But at the same time, no simple, rapid, accurate diagnosis tool available. Microscopic stool examination was what generally people relied on. And it affects not just human, but also animals. And the adult worms don't multiply. One worm remains one worm. But in the intermediate host, the snail, the one mycelium multiplies into hundreds and thousands of cercaria in a series of its similar to propagation in the environment. And the snail itself is very fertile. So in 1993, International Commission on Disease Eradication held at the Carter Center concluded that the disease could not be eradicated at this time, but in its report it stated that effective control of the disease is possible because praziquantel, inexpensive and effective anti-schistosomal drug was available. That's very significant. And the WHO expert committee recommended the following public health program. First, in the areas where the transmission rate is 10% or more, mass administration should be carried out, not only for those who have been diagnosed with the infection, but also for all the people living in the area. And health education to the people is essential. And especially dysentery condition improvement is necessary, such as installation of toilets, the elimination of outside toilet, open defecation, as much as possible, and also the extermination of snails as vectors, and especially in the case of Schistosoma japonicum, measures to control animal infection as additional measures recommended, and transmission rate is monitored and evaluated by periodic stool tests. In 2007, Merck started to donate free praziquantel to children in Africa to fight against schistosomiasis, and in 2013, the WHO also announced its global strategy for the year 2020. In response, pharmaceutical companies provide drugs free of charge or in countries outside Africa, countries or donors procure praziquantel, governments implement control programs, WHO formulates policies, strategies, procurement and research and development of praziquantel is coordinated at a global level, and donors and partner organizations provide financial support to implement control activities. Donors and partner organizations provide financial and grassroots support for the implementation of control activities, and many university research institutions are involved in research and studies as well as private sectors. As a result, although in some countries, mass drug administration has not yet started in some countries, but in most of the countries, mass drug administration is being carried out every year. The green column shows countries where transmission has been reported to have been stopped. Japan is among them. The blue on the right shows the number of people reported to have received mass medication among the estimated population living in the risk areas who need mass medication, and coverage of all age groups and coverage among the children. In 2017, coverage of mass medication among children living in risk areas reached 70% on the globe, and with more than 85 million people worldwide receiving mass medication each year to combat schistosomiasis. In addition, some countries are slowly coming closer to control of the disease as a result of nearly 20 years of annual mass medication. For example, Cambodia and Laos in Southeast Asia are good examples, and the graph below shows the results of a fixed point observation of the transmission rate of schistosomiasis in Cambodia using stool tests. And because mass administration is done every year, in many endemic countries, transmission rate is less than 1%. It has become difficult to find infected people by stool tests alone. In such a situation, there are several major challenges to be overcoming in order to further promote the control and suppression of schistosomiasis. The first is we are relying on low-precision microscopic tests and stool tests, and do not have diagnostic tools that can be used in areas with low transmission rates. In areas where there are few infected people, it is not easy and very efficient to find eggs in a small stool sample under a microscope. And as for the countermeasures, praziquantel doesn't include the children under 5 years of age as eligible population. That does not necessarily mean it is dangerous for children under 5, but rather there have not been many trials to guarantee safety in children under 5. So not much data. But there is another problem with the existing praziquantel tablets. The tablets are quite large. Even adults are reluctant to take them, and they are also very bitter. And even if we try to administer them to children, by crushing, they may not be able to take by mouth because it's so bitter. In this regard, pediatric formulation was developed with the support of GHIT. And also, the current praziquantel donation program only targets children in Africa and children over the age of 6 receiving mass medication. In many countries, adults don't receive mass medication. And of course, adults are also infected and as a cause of transmission. So mass dosing of children alone doesn't have much impact on the transmission of the parasite. Everyone continues to be infected. But in countries like the Philippines, where the control has been going on for decades, and it's difficult to achieve a high coverage of mass medication among adults. And sanitation, snail control, animal control are particularly difficult to implement without funding. So there is very limited evidence to demonstrate how much sanitation reduces the transmission, or what animal control measures are necessary and most cost-effective. So WHO will release a new global level NTD roadmap for 2030 this year, in which the target is for all endemic countries to have at least the control of schistosomiasis as a public health problem by 2030. And WHO is looking forward to the day that this tablet will be actually available in all countries in order to achieve the goal that one of the priorities in the heat map that shows the gap areas about disease is to expand MDA to all age groups. Thank you very much, Dr. Yajima. So in order to control schistosomiasis, what are the importance of praziquantel that's discussed? And it may not be generally well known, but in her presentations, we used to have this infection in our countries, and you may feel that this is something close to us as well. And also in her presentation, praziquantel itself in the control of schistosomiasis has an important role to play. And in order to approach the academia and public and private partnerships are very important. That's also discussed. Also, so far, preschool-aged children couldn't have this administration, but thanks to this new formulation, now it will become available.
Our next speaker is Dr. Hiroyuki Kojima, Senior Vice President of the Pharmaceutical Research and Technology Labs, Pharmaceutical Technology Division, Astellas Pharma Inc., and Associate Professor at the Kyushu University. Dr. Kojima has been involved in the development of pediatric formulation of praziquantel for several years. Since 2012, many of you may remember his face from the short movie that the GHIT produced in collaboration with the consortium. Dr. Kojima will talk about the path to the development of the formulation, various trials and errors, and the secret story behind its development. Over to you, Dr. Kojima. Thank you very much for your kind introduction, Dr. Urabe, and thank you very much for offering me the opportunity to talk today. I'm Kojima from Astellas. I'd like to talk about the history of the development of the praziquantel. So earlier, Dr. Yajima talked about the praziquantel, so I'd like to go very quickly about this. The schistosomiasis is a prevalent NTD, especially in Africa, and the praziquantel was developed by Merck in 1970, and it has a quite high efficacy and safety. But for the pediatric patients, so the issues of praziquantel is that there is unmet medical needs in the pediatric patients, especially for the preschoolers. It is used on the off-label basis. And also the size of this tablet is quite big. It's more than a 10 yen coin. And so since it is very big, the small children cannot use. And also sometimes it is ground. The tablet is ground, but actually it's quite bitter. And the children, it causes the children to gag or vomit, and it works by only one single dose, but you cannot treat the preschoolers. And so since I'm in researcher of the formulation, I thought about what we can do. And of course, the drug needs to have some active ingredient, some kind of effect, a chemical effect. But unless you have a good formulation, the drug is not accessible for certain population. In the case of praziquantel, even if it is efficacious, but there is no good formulation or the dosage form for the millions of children in the world. And so we learned that, and so we thought maybe we can help them by using our formulation technology. So that is why we joined the consortium. And around 2012 or 2013, this was the structure of the partnership. And there are additional members later on, but we joined as a member of the consortium in 2012. And there are partners and the funders, including the GHIT. There are many collaborations, and then eventually the phase 3 study was completed successfully, and I'm quite glad about that. So let me show you two important keywords. It's pediatric and the developing countries. Those are two important keywords for our project. And regarding the physiological characteristics of the children, as you may know, the children are not small adults. So physiologically, for example, the children has a smaller amount of the intragastric fluid, and also the gastric pH is different. And so in the newborn, it's close to neutral. So the GI tract function is quite different, and so it may affect, the difference may affect the drug absorption. And also the specific the dosage form is necessary for children. This praziquantel, the formulation is targeting this 3 months to 6 years. And of course, those children are different in terms of the body weight, and so the dose adjustment is needed. And also the excipients. We have to add excipients for the API, and so there are only limited the amount of the excipients that are available for children, that are allowed to use for children. And so the most important thing for the praziquantel is the taste. It needs to be a good taste, acceptable taste, to have it taken by children. And starting from the late 1990, our company has been working on the orally disintegrating tablet. It's ODT. It's a quite major dosage form now, but our company is the first one to launch such a tablet in Japan. And also we have the multiple technology to suppress bitterness. So based upon our experience, we were able to support the project. On the other hand, there are also two keys for the formulation development, and the AS. It's affordable and sustainable. And so when we joined the consortium in 2012, we thought that we shouldn't use a high technology, but rather we should use the technology level where issues can be overcome, so that the local companies can continue to produce that. And also it should be affordable. And this is what they developed. In terms of the size, it's 1/4 of the traditional one, and the dose adjustment is possible. And also due to thanks to the excipients, the bitterness is suppressed, and it can be taken without water, especially for the small children. You can suspend this with a small amount of water and have the children take that. And also, since this is stored in the tropical area, so we also consider the hot and humid climate, and also it is easy to manufacture. And that's what we considered when we developed that. And again, ODT, it will be disintegrated within 1 minute, and it can be used for infants and toddlers. And also suppressing the bitterness. This was the most difficult thing for us. We screened several excipients, and we try to find safe and also suppresses the bitterness. And we mixed that in the dosage form. Also, for the binder, there is a binder for formulating the tablet. So when we transfer those tablets, we don't want those tablets be destroyed by some vibration or shaking. And so the tablet needs to have some kind of hardness, but we want a tablet to be disintegrated quickly. So there is a two contradictory nature, and in that usually high molecular high molecular weight compounds are used for the tablets, but thinking about affordability and sustainability, we decided to use cornstarch as a binder because it is a natural origin from natural origin and affordable. So this is how we developed the formulation.
And in Japan, we finished the design of the formulation, and then racemic formed, and also the optically active isomers or substance. Those were available, and we did the technological transfer to the partners, and then we prepared this for the clinical trials conduct. And this is the taste or palatability tests and study. We thought that we could come up with appropriate formulation. However, the sensitivity of the taste differs from people to people, where to live, and what is the usual food they take. So in Africa, in children, we requested them to try the tablet, whether or not they can accept the taste. And we were so nervous whether or not it can be accepted by the African children. So we had a certain concern, but at the same time, we expected, because we thought that we did everything we do to come up with the best formulation. But in phase 3, this L-form praziquantel was successfully utilized. And in this case, the graph showing if it is to go up, then the taste is better. And currently, the adult formulation is quite bitter. The taste is bad. But what we newly developed, the new formulation, that taste was much better, and children accepted it. And in our palatability study, we could pass. And for the formulation development part, we could finish our work. Then coming to this point of the stage, you may feel that it is a rather straightforward development process. However, actually, there was a long way to come to this point. First, there was a prototype that we discontinued development. That was a mini tablet, as you can see here. This is the adult formulation tablet. And using that, we produced a small tablet with a coating for several hours because the drug inside doesn't melt out. Therefore, there is no bitterness. And we thought, discussing with the consortium member, that we can use this for the clinical trials. But after we finished formulation development in September 2012, then it was actually commented by the expert committee members that it is not appropriate as a formulation for pediatric use. Even children, in the case of the children with heavy body weight, they have to take a lot. And also, in the case of small children, there may be a risk of the erroneous swallowing and asphyxiation. Therefore, it was discussed, and it is not really a good idea to have these mini tablets, and we decided to develop orally dispersible tablets. And together with Merck back in those days, concerning praziquantel pediatric formulation development, we had a joint technical discussion for the first time in November 2011. And then 10 years after that, we could give a press release of the phase 3 study completion last month this year. So it took 10 years, starting with a mini tablet as an idea, changing to the ODT, and then that pediatric formulation is now finished its clinical trials, and it is now very close to the submission, filing, and approval. So this is my last slide. So originally, we started our work that we wanted to contribute with our formulation technology to save children with MTDs. And with a keyword, the children and developing countries, we developed formulations. And actually, we didn't have any accumulated know-how to develop the pediatric formulation, but now we could accumulate, and those could be applied into our own product development. And even in the academic activities, we are on the executive committee for the formulation of pediatric drugs in the academic society. And with this novel technology of formulation, we will create a novel medicine to make a contribution to those children. And such a passion of a consortium partner and GHIT actually came into this form of a success. Thank you very much. This is the end of my presentation. Thank you very much, Dr. Kojima. With Japanese formulation technology, the medicine development, not just the size, but also the taste, and also physiological features of children have to be taken into account. You need also to select additives, excipients, and also the conditions have to be defined for the appropriate oral disintegration, and you need to guarantee affordability, sustainability. So, so many issues and challenges you have had so far in the process of development of 10 years, and you cleared all those one by one. And now you come up with this new formulation, praziquantel. And now, as a founder, we are very pleased as a GHIT Fund that we could support this to be delivered to children in Africa.
Next, I'd like to invite Dr. Okuba Hajali from Merck. Dr. Hajali will give us an overview of the phase 3 trial that have been completed. This will be the first time that the data from the phase 3 trial will be made public, so it's exciting. Over to you, Dr. Hajali.
Thanks a lot, Hayato. So I hope you can see my screen. Put it. So first of all, I want to thank you on behalf of the consortium for the opportunity to present the positive pivotal study result of arpraziquantel for the treatment of intestinal urinary schistosomiasis in preschool-aged children. The clinical development plan of arpraziquantel included 2 phase 1 studies. We started with that to evaluate the bioavailability of the compound versus the racemic praziquantel, as well as another ODT formulation that finally was ruled out. And both were performed, both studies in South Africa. In addition, we ran a taste study that was completed in Tanzania in children to evaluate 2 different ODT formulations. And finally, we decided to go to the phase 2 study with the enantiomer arpraziquantel in a dose-ranging study that we ran in Côte d'Ivoire in children 3 months to 6 years old with infection by Schistosoma mannsoni, showing that arpraziquantel at a dose of 50 milligrams per kilogram was efficacious and safe, as well as comparing to biltricide in different regimens, 40 milligrams per kilogram, which is what WHO recommends in the MDA administration, or the labeling recommended dose of 20 milligrams per kilogram 3 times in a single day dosing. It was comparable in terms of efficacy and safety. And finally, the 50 milligrams per kilogram dose was used in the phase 3 confirmatory pivotal study that we ran in Kenya and Côte d'Ivoire. Finally, we recruit children in the pivotal study with Schistosoma mannsoni and Schistosoma hematobium infection. It was the first time we evaluated the product in the hematobium species in the same age range we have in the phase 2 study. So as you can see here, the pivotal study design that was agreed with European Medicines Agency before the study kickoff consisted on 3 cohorts of subjects with intestinal schistosomiasis. So as you can see in blue, we have here 3 different cohorts according to the different age groups. So in cohort 1, we had a randomized setting to 2 treatment groups consistent of treatment with arpraziquantel or the second treatment group, subject treated with biltricide. In addition to those subjects in which we had randomization in subject 4 to 6 years old, we had a very important group, which is cohort 3, the youngest preschool children, 3 to 24 months of age. And we pooled this subset of subjects with the same age group recruited in the phase 2 study. Follow-up was established for those Esmanson-I cohort at the 3rd week post-treatment, according to the WHO recommendations. And in addition, we had the cohort 4 of children, again, aged 3 months to 6 years old with urinary schistosomiasis that were treated initially at the same dose of 50 milligrams per kilogram, but considering this was the first time we evaluated this species, we had an interim analysis after the first 30 subjects treated, and it was decided in agreement following the IDMC recommendation to increase the dose to 60 milligrams per kilogram due to not a completely satisfactory cure rate. So we opened the cohort 4B, in which we included 60 subjects, including in addition a second time point of follow-up for the efficacy at the 5th week post-treatment, in addition to keeping the previous one of 3rd week post-treatment. The main endpoint was clinical cure at the 3rd week post-treatment for the Esmanson-I infected subjects, specifying the efficacy threshold for the trial success as 70% for the lower bound of the 95% confidence interval. It was a quite high threshold, but that was the minimum acceptable by EMA, instead of the fact that WHO considers egg reduction rate the main criteria for evaluating the treatment succeed. Clinical cure in the rest of cohorts at the 3rd week post-treatment, as well as 5th week post-treatment for the cohort 4B for the urinary schistosomiasis, was defined as secondary endpoint, as well as egg reduction rate, safety, and palatability assessments. So the main inclusion criteria were an age from 3 months to 6 years, an infection by Schistosoma mannsoni or Schistosoma hematobium, meaning we are excluding mixed infections. The minimum body weight was 5 kilograms, and we, as usual, included as a criteria having parental consent, as usual in clinical research settings. Subjects with medical conditions such as seizures were excluded, as well as the presence of cysticercosis, clinical cysticercosis, as well as debilitating illnesses according to the praziquantel labeling, and in order to avoid the risk of immunocompromise. Subjects treated with antimalarials 2 weeks before screening were excluded due to the fact that some of them had anti-schistosome activity, as well as products that might interfere with the praziquantel metabolism. So in this disposition chart, you can see that almost 2,700 subjects were pre-screened in both countries, Kenya and Côte d'Ivoire, facing sometimes extreme difficulties in the access to remote villages for finding the study population. You have to consider that those diseases are not present usually in urban areas, but in rural, remote areas. So that was a difficulty that we faced across the trial recruitment. A total finally of 326 subjects were screened and 288 were enrolled. Those were the safety analysis set. Finally, 8 of them were excluded due to the use of antimalarials that could induce or help to induce cure. And finally, the modified intention to treat population, which is the population we used for the efficacy assessment, was composed of 280 subjects, quite close to the number of enrolled, thanks to the great work during the follow-up of the study sites personnel. Looking at the demographic in the mITT population, it's important to mention that for cohort 1, it was pre-established and agreed with EMA having at least 40% of the population with moderate heavy infection intensity in order to understand the behavior of the drug in both settings, light infected and heavily infected subjects, while for the rest of the cohorts, in general, the infection intensity was in line with the epidemiology of the disease in the sub-Saharan Africa area, excepting for cohort 2, as you can see here, we had almost 60% of the subjects heavily infected because we recruited in some areas with hotspots. The anthropometric measurements were consistent with the age groups recruited in each cohort. So here we are presenting the cure rate, which was the primary endpoint for S-Mansoni infected subject. Important to say that in cohort 1, arpraziquantel met the pre-specified efficacy threshold for success, reaching a cure rate comparable to biltrexide. It's important to say that it's true that you have in the dotted lines here the threshold for the lower bound, but the fact that biltrexide did not meet these criteria, it's only because we had 50 subjects in this treatment group, while for cohort 1A we had almost 100. So at the end, comparable results. When we compare the cure rate across the different S-Mansoni groups that you can see in the green bars, it's quite comparable and consistent, not only within this trial, but even with the phase 2 study, as well as with the limited number of published trials in preschool-aged children. For S-hematobium, it was clear that from the first interim analysis result of the first 30 patients treated at the 50 milligram per kilogram dose, there is a clear increase in cure rate when we increase the dose at 60 milligram per kilogram. And another important message is that delayed assessment 5-week post-treatment achieved a tendency to better cure rates. That means probably in research settings, we might require a delayed assessment for S-hematobium infections, probably due to differences in the parasite life cycle compared with S-Mansoni. Interestingly, the pooled analysis of the very young children, preschool-age children recruited in the phase 2 and 3 studies was matching with the cure rate obtained in both studies considered alone, pointing to the fact that both populations and outcomes are comparable in both studies. So it's appropriate pooling this population. A very high egg reduction rate was obtained across the different groups, even in the first interim analysis of the S-hematobium infected subject at 50 milligram per kilogram. It was around or above 99%, which predict an excellent control of the morbidities in the short term and in the long term for both intestinal and urinary schistosomiasis, meeting the WHO requirement of an egg reduction rate above of 90%. This is important, as my colleague Benjamin Dälken mentioned it, because in the short term, we are preventing some issues as anemia, hepatosplenomegalia, cognitive and developmental impairment. But in addition, in the long term, we can prevent not only cirrhosis, but even bladder cancer in subjects with urinary schistosomiasis that are both a big burden for the healthcare systems in sub-Saharan Africa. Regarding the safety in general, treatment emergent adverse events were more frequent in the S-Mansoni cohorts, as you can see here. And the same trend was maintained in the IMP, so drug-related adverse events. No IMP-related serious adverse events were reported, neither deaths nor discontinuations due to the adverse events. And only one subject had a severe adverse event related to the IMP in cohort 2, being abdominal pain, which is probably related with the fact that the subject had high infection intensity at baseline, but anyway, that was resolved without sequels in the 48 hours post-treatment. In line with the praziquantel reported safety profile, the drug-related adverse events were mainly gastrointestinal, as you can see, quite comparable between arpraziquantel and biltricide. You can see here 28% versus 26%, and slightly higher in cohort 2 due to the fact that in this cohort, the baseline infection intensity was higher. So that produced a massive parasite killing associated with those gastrointestinal disorders. In addition, we had some cases of somnolence, comparable again between cohort 1A and biltricide cohort 1B as internal control, usually in subjects with some hydroelectrolytic disbalance due to the presence of diarrhea and vomiting. For the hematoma-infected subjects, there was a clear tendency to lower incidence of treatment emergent adverse events and quite comparable safety profile between both dose regimens. Regarding the palatability assessment, arpraziquantel showed across all the cohorts better and improved palatability score, in which higher scores means better palatability. It's important to mention that we evaluated that in subjects 5 to 6 years old, that are the best reporters that usually in pediatric trials are selected for the palatability assessment. So key conclusions can be summarized in a favorable profile in terms of efficacy and safety for both species and at both doses, 50 and 60 milligrams per kilogram. The study met the primary endpoint with a lower bound of the 95% confidence interval above 70%, with cure rates very close to 90%. The product achieved 99% egg reduction rate across the different cohorts, predicting an excellent morbidity control. The study did not show any new potential safety risks, and palatability was improved through this new product formulation. And finally, I cannot close the presentation without giving big thanks to all our consortium partners, to the clinical trial staff that did the impossible to complete this trial even in spite of the pandemic, our investigators for the continued support, and the most important thing, our stakeholders, the children and parents that participated and made possible this successful trial. Thanks a lot.
ハジャリさん、どうもありがとうございました。ハジャリさんはスペインから今回入っていただいて。
Thank you very much, Dr. Hajari. You are participating now from Spain. And in Dr. Yajima's presentation, there are 5 main species that's mentioned in schistosomiasis. But this result regarding 2 major species, study were conducted, and praziquantel efficacy has been demonstrated in both. That's quite encouraging. And other praziquantel can be utilized for broad applications. And also safety profile is also quite favorable. That's good information. Thank you very much for your sharing the most recent data.
For the last speaker, let's connect to Kenya, one of the clinical trial sites. One of the people behind this clinical trial is Dr. Maurice O'Dea, the principal research scientist at the Kenya Medical Research Institute, KEMRI. Dr. O'Dea will talk about the experience with the clinical trial and the impact that our praziquantel will have. Over to you, Dr. O'Dea.
Thank you so much, Hayato, for the introduction and for the speakers who came before me. My name is Boris Odera. I'm a research scientist at the Kenya Medical Research Institute. I also served as the principal investigator for this phase 3 clinical trial. And I'm happy to take you through some of the experiences that we went through to achieve these hard-earned results. As you will appreciate, working in this LMIC countries comes with its own challenges, so I'll try and share some of those with you. So my presentation is structured in four sections. I'll give you a brief background on the schistosomiasis situation in Kenya and KEMRI's role in disease control. Then I'll talk about some of the...
Mr. Deere, Dr. Deere, I think your slides are not on the presentation mode, so maybe if you don't mind, maybe we can share the slides for you. If I know we've been just trying for some time, but if that's okay with you, we can share the slides for you.
Sure, please.
Thank you.
Sorry about that.
Sorry for that. Thank you. Okay, you're on. Thank you.
Yes, sorry about that. Yeah, so just a quick recap that I said. I'm a research scientist at KEMRI, and I want to share with you some of the experiences that we went through during the conduct of this phase 3 clinical trial. Next slide, please. Yeah, so the presentation is structured in 4 sections. I'll give some overview on the situation in Kenya, and then some experiences through the clinical trial, and then how the pediatric praziquantel will bring positive impact, and then next steps in terms of access to ensure that these children who need these medications receive them. Next slide, please. So KEMRI joined the consortium in the first quarter of 2018. Of course, there have been different partners that have joined and some that have left, and this has already been mentioned. Next slide, please. Yes, and just a brief background on KEMRI. KEMRI is a research institution. It's a state corporation that's responsible for carrying out research for human health in Kenya. It has 11 research centers that are distributed across the country. Of course, the biggest majority are in Nairobi, but one of the research centers where I'm based is called the Center for Global Health Research, which is located in Western Kenya, where also the clinical trial was conducted. And basically, KEMRI's mission is to improve the human health and quality of life through research, capacity building, and innovation and service delivery. And one of the ways this research is organized at KEMRI is through research programs. There are 6 research programs, one of which is the infectious and parasitic diseases program, which also focuses on neglected tropical diseases where schistosomiasis falls. Next slide, please. So before I go into sharing some of the work that we did, just to give some contextual background, in Kenya, there are 3 main endemic regions that are recognized for schistosomiasis. We have mainly the coastal region where we have the Schistosoma hematobium that's colored in the dark red on the screen. And then we have the lower eastern parts and central sections of Kenya where we have both species, the Mansoni and the hematobium. And then we have the Lake Victoria Basin, which is in the western front of region, where we have mainly the Schistosoma Mansoni, but with few pockets further inland where we also have a hematobium. Now, in terms of the disease burden in Kenya, we see this spanning in 62 out of the 290 sub-counties. About 6 million people are believed to be infected, a huge chunk of this being the school-aged children, about 70%. But also there are estimates that show about between 130,000 to 250,000 preschool-aged children are also infected with the disease. And even then, that's a very conservative estimate. Next slide, please. Next. Yeah, so this slide basically just presents some of the risk factors that are associated with transmission in this particular setting. Sorry, just the previous slide. Yes, but so we will see activities such as car washing, fishing, sand harvesting, and laundry. And among those activities, as you will see, there's always been a question as how do these young children really get infected, or what is really driving the infections? And we can see on the lower right-hand panel where those women are doing their domestic chores, they carry these women along with them to the water points, and some of them will play in the water if they are of reasonable age that they can swim and play around. And those ones who can't play sometimes are put in buckets of water, and transmission actually takes place. Next slide, please. Yes, and so this slide is borrowed from Russell Stothard's work that they did around Lake Victoria, and shows a nice photo of a child sitting in a bucket, and you can clearly see how transmission will be taking place in some of those settings where even the water is cooked from the lake or from the water point, but it's still brought at home, and the children, these young children, sit in those buckets. Now, in terms of the need for treatment in these kids, we know that current control strategies target mainly the school-age children, and Kenya is not an exclusion, as in many other endemic countries. Preventive chemotherapy is provided through the school platform, usually the national school-based deworming programs. And then we know that this continuously excludes these young children who are not yet enrolled from receiving these interventions. Next slide, please. Next. Yes, and so some of the consequences of those systematic exclusion include these serious morbidities that we see in children. For instance, in this particular case, you can clearly see a case of hepatosplenomegaly. And also the other consequence, of course, is the fact that we have set up ambitious targets, with our roadmaps and also our national targets. And we can clearly see that this systematic exclusion of these young children from treatment continues to harbor a reservoir that keeps on carrying on the transmission, and so this will definitely hamper our elimination targets into the future. Next, please. And so, in terms of some of the experiences that we've gone through, next, please, in conducting the trial, I think the best way to appreciate this is I try to summarize this in a slide, where we basically showcasing the challenge and then whether it affected the study or not. So, of course, the one tops on the list, of course, would be, we cannot forget the current setting we are working in now with the current COVID-19 pandemic. Yes, this affected our study. We had a temporal suspension for about 6 months, and this is not, of course, unique to our situation in Kenya, because it's a global phenomenon. And then we, of course, the other one that I mentioned at the outset is the fact that conducting clinical trials in low and middle income countries comes with its own challenges due to weak or inadequate local clinical trial human resource capacities, and also infrastructure, and also the high thresholds that have been placed, to meet these global standards, the ICH GCP compliant trials. So in our case, the way we try to mitigate this is we try to hire some of the staff who had prior experience in conducting clinical trials, in working in clinical trials. And so those ones then received trainings, and it was very easy to bring them up to speed with what we wanted to do. Of course, in terms of the infrastructure, we had to do refurbishments of spaces so that we can house the trial. And then we also had to do equipment purchase. And then weak or inadequate regulatory capacity for ethical and regulatory oversight is also another challenge that is common in conducting studies in this setting. In our case, this was not really a big challenge. As I mentioned, KEMRI has been conducting research for the last over 4 decades, and we have got very robust and well-developed regulatory and ethical oversight systems in place. The other challenge also is the one that's tied to the cultural and geographical differences. There are issues to do with how do you obtain valid informed consent, issues about transport reimbursements, what is adequate compensation for that, trial insurance, collection of blood is always a sensitive issue. There are lots of rumors and misconceptions around blood as a sample. What is the reasonable standard of care? And then issues such as terms such as legally accepted representative versus use of guardian. In some of our settings, we might not necessarily be able to provide court documents to show that, these are legally acceptable representative. And so what we had to do is it's required for us to sometimes revise informed consent forms. We did a lot of community sensitization. We worked very closely with our IRB to iron out some of the issues, and then we also addressed any rumors or misconception in a very timely manner as soon as they emerged in the field. Next slide, please. Yes, and the other challenge, of course, institutional bureaucracy is again not unique to our institution. Slow turnaround in procurement processes, so which required us to submit requests early enough in good time, working closely with the relevant departments that provide approvals. This was the same thing with regards to delays in supply chains and customs issues, especially for international procurement, where we were buying the point of care CCA kits, urine filtration kits that had to come from outside, working very closely with the relevant departments and regulatory authorities. Poor road infrastructure was another challenge that we encountered. This is a low middle income country. We also had to mitigate this by being creative and using the 4x4 cars, getting an extra field team in place so that we can try to cover as much ground as possible, and then also community supported us every time the teams would get stuck out there in the field. The other challenge, of course, was the mixed species. We remember in this study, this was an exclusion criteria. We wanted to look at single infections separately. And so we had to now leverage on our local knowledge of the disease distribution epidemiology, looking at division of vector-borne and vector-borne disease experts, and our experience previously in working in these areas to identify really communities where we can pick those single infections and so forth. And then the other challenge, of course, which is very common, is managing different partner expectations, stakeholder expectations. As you will appreciate, working, when you're working together collaboratively, people come on the table with very different expectations. So we have to be very transparent, have dialogue, and have regular meetings so that any issues that were, popping up could be addressed in a timely manner. Next, please. Next. Yes, so this photo just gives you a flavor of what the challenges were in the field. As you can see there, some of those field teams were stuck in mud, and this is part of the terrain that they were covering when they were out in the field. And you can see they are being supported there to push the car out of the mud. The other setting just shows Lake Victoria and some of the communities. You have areas where it's very villages are, households are very far away from each other, in other settings where they are clustered and so forth. These are just some of the challenges during the fieldwork. Next, please. And so as I indicated, infrastructure is one of the biggest challenges that usually we have in some of these settings, because you don't have your clinical space to be able to start from the outset sometimes. And so here we have to work closely with our local hospital facility. And so we were allocated space at Homa Bay Teaching and Referral Hospital, which is a level 4 facility. It has quite some good infrastructure and also bed space. So we allocated the bed space, which we have to renovate and make it a little bit appealable to the kids. As you'll see on the lower right-hand panel, we did a lot of painting to make sure that this is it really looks like a pediatric unit. Next, please. And then this is part of the ward space. This was the space that we were given. On the left is the space that we were given before the study. And then on the right hand are the two photos that show the work that we had done to renovate the place and get the beds in there and the screening and all that. Next, please. And this is a pharmacy room. We had to, refurbish and create a pharmacy room that's dedicated to the study. And you can clearly see there we had a very fancy one. Next, please. And then, so in terms of what change will come from this formulation, I think there are 4 ways that I would like to look at this. Please, next slide, please. One of the things before we go to that is just to understand what are the challenges that are related to this and why we got here in the first place. First was the issue about the dosing, the tablet size that has been mentioned, the palatability, the beta test, and then the issue around access. And then because of the fact that the drug has been used mostly in off-label and non-licensed in some of the studies. Next, please. So the positive impact that I see coming from this, please click, next, is 4-fold. I would summarize in that regard. First, the unprecedented opportunity to just improve the health and well-being of children. So we are looking forward to that being a very positive impact. That has already been alluded. And then we have really improved the clinical trial infrastructure and capacity building, by just conducting this study. We've created a robust team of clinicians and other field staff that can comfortably work on other trials moving forward. And this is a huge part of capacity building that's also for KEMRI. And then we are also expecting that one of the positive things that will come from this will be the smooth downstream process in relation to the registration, procurement, and delivery of the medicines. Already we know that Universal has been brought on board to, as a CMO. And so we are hoping that our regulatory authority, because we've worked very closely with them and they're very familiar with the activities that we've been conducting, that will streamline and enhance the process. And then also, because of the trial being conducted in a very open manner and bringing everybody on board, it's fostered a lot of local credibility and trust, which also we look forward into tapping to ensure that it will enhance our issues around access to the intervention. And also, this would be a good benchmarking opportunity for other studies and clinical trials because of the nonprofit public-private partnership that we've shown to be able to work. Next, please. Next. Yes, and so the other way to look at it also is the global level, where we know that WHO also listed as a critical area of action. Number 2, they need to come up with interventions that expand preventive chemotherapy to all the other age groups. So we think this is a strong contribution to that, and it will contribute to the 2030 targets. Next, please. And in terms of our local situation here, we know that our universal health coverage is one of the big 4 agenda for the Kenya national government. And so this also contributes to that, because we are providing an intervention that then we can talk about access issues, because you cannot talk about access issues if you do not have the products or the interventions in the first place. And then we also have a breaking transmission strategy by the NTD program, which we hope that one of the strategic objectives is to try and expand treatment to the other groups that have been routinely left out. Again, this contributes and fits in very well in that alignment. Of course, closer home to KEMRI, KEMRI's mission, as I indicated earlier, fits in very well with this, because it's part of improving health and quality of life, but also it also supports that infectious and parasitic diseases programmatic activity, in the sense that it contributes to developing tools and technologies towards the reduction of disease burden associated with schistosomiasis. Next, please. Next. Sorry. Yes, and then, so what is the next steps after this? Next, please. Of course, the obvious natural follow-on is about how do we get these interventions to the people that need them the most. So we have an ADOPT program that KEMRI is also participating in. It involves basically an implementation research component, which is bringing together different stakeholders from pharma, science, and implementation countries, and it's being rolled out in different phases. Trying to understand what would be the barriers, the acceptability issues towards this product once we get out of the field. What type of strategies do we need to develop, to be able to reach? What type of platforms do we need to use to be able to access these populations? And then, of course, there's a post-licensure phase that deals with issues around delivery, monitoring of pharmacovigilance issues, and so forth. So it's going to be a staged approach, which is going to take 5 years from now, 2021 until the year 2025. The pilot countries are 3, that is Kenya and Côte d'Ivoire, of course, the countries where the clinical trial started from. And then, of course, Uganda has been added as a kind of representative of a naive endemic country. Next, please. So the final outcome of what we expect really is from the ADOPT program is an implementation plan that will be backed by policy and donors and supported by a practical toolkit that will then help or guide endemic countries through the preparatory steps as we prepare to introduce this arpraziquantel for pediatric control efforts and through these community settings. Next, please. So just to thank all the consortium partners, all the participants, and the study settings that we worked in, and all the audience for listening, and I'm happy to respond to any questions. Thank you so much.
堀江さん、どうもありがとうございました。
Thank you very much, Dr. Odile. Now, I think over 100 people are listening to this seminar, and it's connected to more than 10 countries now. And from Kenya, the local challenges and the measures taken were discussed, and we could see the pictures, and we could actually feel Kenya very close to us. Dr. Kojima mentioned about formulation challenges, and even beyond formulation, in order to actually conduct local studies, there are many barriers or obstacles that we needed to overcome. And the participants, research and development, as well as the local access and implementation, these have to be made into one, so that we will actually be able to deliver this product in the end to the people who need it. So now we'd like to start the Q&A.
Before we begin the session, I would like to have comments from the designated speakers. two of them. And the first speaker is Dr. Satoshi Ezoe, Director, Global Health Policy Division, Ministry of Foreign Affairs. Dr. Ezoe is unable to attend today due to his official duties, but has left a message which I will read on his behalf. The government of Japan and Ministry of Foreign Affairs, which has supported the GHIT Fund since its inception in 2013, is very pleased with the success of the Pediatric Praziquantel Consortium's phase 3 trial. We would like to express our gratitude for the tireless efforts of the consortium members, donors from other countries, and the government and related organizations in Kenya and Côte d'Ivoire, as well as for the participation and the support of many children, their parents, and the communities who participated in this clinical trial. Based on such successful examples of research and development in the field of global health, the government of Japan and the Ministry of Foreign Affairs will continue to support efforts to achieve universal health coverage through R&D in the fight against neglected tropical diseases, in close cooperation with the relevant ministries and agencies and the GHIT Fund, so that Japan can actively engage the public and the private sectors and deliver as many products as possible to neglected populations. Next year, in 2022, the African Development Conference TEAE will be held in Tunisia. Measures to combat neglected tropical diseases are also included in the TEAE Yokohama Action Plan, and we will continue to actively communicate these success stories and the significance of cross-border partnership through collaboration between Japan, Africa, and other countries. We hope that the GHIT Fund will continue to work closely with partners, including UNDP, in order to deliver medicines to those in need. We look forward to the continued support from all concerned. Satoshi Ezoe, Director, Global Health Policy Division, Ministry of Foreign Affairs. So I am glad that we received the comments from Dr. Ezoe, and we hope that the international organizations such as UNDP will also be involved to lead to the universal health coverage.
Next speaker is Mr. Ikuo Takizawa, Senior Deputy Director General and Senior Director, Office for COVID-19 Response, Human Development Department, Japan International Cooperation Agency, JICA. Now, Mr. Takizawa, please. Thank you very much. I'm Takizawa of JICA. Thank you very much for this opportunity to give you a comment. Praziquantel phase 3 study was so successful, and from 3 perspectives, JICA welcomed this very much and appreciated it very much. First, thanks to GHIT funding support, this may be the very first concrete product. And in the presentations, it was a long way to this point that's mentioned. But the consortium made a great contribution so far, including the GHIT, and all those partners, supporters, come along the long way and come to this success. And for that, I'd like to congratulate you all. And secondly, KEMRI, Kenya Medical Research Institute, that is a long-lasting partner of JICA, has been also involved in this consortium, playing one of the leading roles. And these participants today maybe have a good knowledge of KEMRI. And KEMRI is actually, in 1979, starting from the building constructions as non-charged support from Japan government, and actually I think it could be said that Japan and Kenya worked together to actually develop and construct this KEMRI. Of course, it's not just the 2 countries, but many others cooperated. And regarding schistosomiasis, Nagasaki University has been engaged for a long time in terms of enhancement of research capabilities there. So in that sense, praziquantel development per se, JICA was not involved. However, indirectly, I believe that we could make also some contributions to this formulation development. For over 40 years, Japan has been supporting this consortium, in this consortium, and African countries. There are clinical trials ongoing in Zambia University, and JICA is also helping them to develop, and some of them have grown to be a global research institute, a medical center now. So the drug discoveries or vaccine development partnership, those kind of programs also started up in Africa. So in drug research field, not just Africa, but also all the developing countries, researchers, scientists are participating, which will accelerate those researches and development. We would like to accelerate those efforts, and we would like to see the continued fruits of those acceleration from the institute centers, not just from the ones that we have been supporting, but also from the other ones. And their formulation will become a game changer of the control of schistosomiasis. And we need, however, the support to make this product to be a real game changer. And for that end, JICA would like to also extend the support. For instance, for filarial control, we are working with WHO and national governments, and also Eisai from Japan has been contributing by providing treatment drugs. So that's another partnership. And in Bangladesh filarial control, there are similar programs ongoing. And also in Ghana, Guinea fever eradication. And also it's not an NTD, but for polio eradication, we also had those collaborations. So in various field and space, regionally or globally or locally, JICA has presidents fighting against those diseases. So now, having this praziquantel new formulation, we have a new product to combat against the disease, and I wish that everyone here will continue to make consolidated efforts. Thank you very much. Connecting Japan and the other countries on the globe, we may be able to also some point in the future directly cooperate with JICA. So I'm looking forward to that. Thank you very much for your comment.
Now we'd like to move on to the Q&A session. We received several questions from the audience, and we'd like to respond or to have the speakers respond to them as time allows. And the first question is to Dr. Yashima. And the question is that the prevalence of in the endemic area, and also the frequency of infection. Does it actually do people get infected several times a year? For example, what's the frequency? Dr. Yajima, please. Thank you. The ratio prevalence. Well, it depends on the prevalence. As Dr. Morris mentioned, it depends on the area. In one area, different areas have a different prevalence, and so if it's in some area, if it's over 50%, that means that more than half of the people are infected. But actually, in most of those areas, MDA, mass drug administration, is done. So the prevalence rate is not usually that high, but in many countries, for example, in the Laos, and the prevalence like 70% for some time, but because of the MDA, the prevalence was reduced, and so they stopped the MDA. But actually, then in 2 or 3 years, the prevalence just jumped up to 50% to 60%. So depending on the situation, the ratio of those people infected is different. And regarding the frequency, so if you take the praziquantel and then if you are infected, yes, you get infected again. That's the answer.
Thank you. Next question. I think it goes to Dr. Okuba or Dr. Benjamin. These clinical trials, subjects are preschool-aged children from 3 months old to 6 years of old with schistosomiasis. And probably the product will be listed on WHO's pre-qualified medicine, and then it will be given to preschool-aged children in Africa. And is it going to be administered only after diagnosis is given, or it will be administered as a part of MDA? Either Dr. Benjamin or Dr. Okuba, could you raise your hand if you want to answer, please?
Yes.
Dr. Okuba.
Thank you. So basically, both strategies are expected to be covered, but I mean, remember, we will get positive opinion from the European Medicines Agency for the cure indication, but that doesn't prevent WHO for apply after the pre-qualification process the chemoprevention strategy. So that means that the product will probably be pre-qualified and recommended by WHO for MDA settings for preventing the disease. So it's something compatible, but usually in sub-Saharan Africa, subjects are treated once a year. This is what is recommended for school-age children. And in areas with very high prevalence, it's twice a year. But anyway, considering the baseline infection intensity in preschoolers used to be light, probably once a year will be what WHO will recommend. But let's wait and not preclude anything until having the guidance to be released for preschool-age children management in schistosomiasis by WHO.
はい、ありがとうございました。奥葉さん、ありがとうございました。そうしましたら、次の質問ですね。こちらは小島さんに対してのご質問かなと思っております。
The question is probably Dr. Kojima, you talked about the formulation techniques, and so those techniques can also be used for other diseases? That's the question. Thank you for your question. Yes, basically, the answer is yes, especially the one we produce, the affordability and the sustainability point of view was used, and for it could be applied to other NTD. But of course, we have to have a good match of the API and the excipients. So the compatibility need to be good. So and also the quality of the formulation. Yes, we need to assess that. But technically, I believe that that technique is rather easy to apply to others. And so that could potentially be used for other NTD. Thank you.
This may be applicable to other NTDs. That's quite encouraging. I wish that it will be used in an extensive manner.
そうしましたら皆様、本日は、小児用プラジカンテルコンソーシアムと GHIT ファンドが共催するウェビナーにご参加いただきどうもありがとうございました。ちょっと時間になりましたので、終わりにしたい。
Thank you very much for the participants for this webinar, co-sponsored by the Pediatric Praziquantel Consortium and the GHIT Fund. And last night, we held a webinar for the listeners in Europe and Africa. And there, the question was asked, what's needed for such a global consortium? And mutual trust was mentioned. So in order to create and maintain international consortium, it is a gathering of people with a different background. And one thing connecting these people is trust. And this time, various brains of people in the world were connected, and Pediatric Praziquantel is now become available. Through the process of development and access, now I think we can see a concrete path that we will be able to deliver this product to children who need this. And I wish that you continue to support Praziquantel Consortium and the GHIT. After finishing this webinar, on the screen there will be a questionnaire survey appearing. Please also fill in the questionnaire. Thank you very much for your listening until the very end of the program.